we have understood that what are the typical driving modes that any user or you and me go on a daily basis. And also we understood qualitatively what are the torque and the power required by the motor. But one thing is very clear, every driving modes exert some sort of external obstacle force, and that's where motor is there to overcome those forces. So let's figure it out, what are those external obstacle forces actually acting on the vehicle when it tries to move forward. So here I have taken a very general case where road is having a gradient of, let's say, angle theta, and the car is moving on this inclined road with velocity or speed vt and having an acceleration a. So the first obstacle force that car experience is the air drag force. And just to give you an idea of it, let's say car is moving inside the water. So as soon as it starts moving, it experiences a huge resistance force from the water, and this force kept on increasing as the speed increases. What happens on the road? This water is replaced by the another fluid called air, and the amount of air drag force will be calculated using this formula, which is half rho a c d v square. What is rho? Rho is nothing but the density of the fluid or air density. A is the projected frontal area, and CD is the drag coefficient, and the V is the relative velocity of the car with respect to wind. Now, this component, which is the V square, is the kind of dangerous component. Why? Because at the low speed, the air drag force will be negligible or very less, but at the high speed, it becomes so dominant. Let's say car is going at the max speed, there this force will come into the picture, and motor has to provide the equivalent force or a torque to overcome these forces. So this is all about air drag force.